Welcome back, Math 9 students. This is the Flipped Classroom series. I'm Mr. McKimmon. These lessons have been designed and presented by Mr. Gill and Mr. McKimmon. We are currently working through Math 9, Chapter 7.3. Before we get a little bit flipped, I've had a few requests. For what, you may ask? Well, it's for a few pre-lesson jokes. So let's start off with, what did the O say to the 8? Nice belt. What did the acorn say when it grew up? Geometry. Well, actually it was gee, I'm a tree. What do you call an empty parrot cage? Polygon. And the last but not least, how do you make time fly? You throw a clock out the window. All right, let's begin our next flip math class lesson. All right, Chapter 7.3, Multiplying and Dividing Polynomials. Lesson 3 is dividing polynomials by monomials. Remember, as we go through, look at the prefix. Remember, a monomial has one term. A binomial, just like a bicycle, has two terms, two wheels, bicycle, binomial. Okay, tricycle has three wheels, so a trinomial has three terms. So here we have example 1, divide a polynomial by a monomial. We're going to look at two methods. We're going to look first at the model method. So determine the quotient for 6x squared minus 8x, all divided by 2x. Now remember, quotient is the answer to a division question. What is a product? Answer to a multiplication question. What is a sum? The answer to an addition question, and of course the difference is the answer to a subtraction question. Okay, really important to remember those terms because they will show up in word problems. All right, let's have a look here. The solution. So we have here, Mr. Gill has this set up the opposite side. Okay, here we go. So we have set up in this area here. That is what, if we were multiplying this side here by this side here, this center portion would be our product. But because we're doing division, we can use the fact that if we have 5 times 7, that will give us a product of 35. Well, if we were missing the 5 or the 7, we could solve this by dividing 35 by 5, that would give us 7. And if we divided 35 by 7, that would give us 5. We can use this principle when we're dealing with the polynomials. So right now in the center, we have 1, 2, 3, 4, 5, 6x squared. We have negative 1, 2, 3, 4, 5, 6, 7, and negative 8x. Now we're going to divide that by our 2x, and we're going to come up with the other factor, which will in this case be our quotient. Excuse me. So if we look at the first box here, we have an x squared. Well, we can fill in this model by saying, here's my 1x. What would I multiply 1x by to get x squared? Well, that's going to simply be an x here, which I'm going to put this right in there. Okay, so again, we look over to the next one. Now, just like your multiplication table, we start with the x on the side. What would we multiply that x by to get this x squared, well, again, that's going to be an x. And we can continue this pattern on. All right, now we get to the end here, and we're dealing with, in our model, which looks, as I have mentioned, a lot like a multiplication table, we have our x, and we're going to multiply it to get a negative x. Well, what would I multiply x by to get negative x? Well, of course, that's going to be a negative 1. And we're going to fill in that for each of these spots. All right. And our quotient, then, is read by, we have 1x, 2x, 3x, and 1, 2, 3, 4 negatives, or negative 4. So we have 3x minus 4. Just going to slide it down here. Now we can check our answer just to make sure that we got it correct. Remember that we started with the 2x. So that's right here. There's 1x. There's 2x. That's here. And then we're going to multiply that by 3x minus 4. Now remember that we can use a distributive property, and when we multiply, we must first multiply the first two terms. So 2x times 3x, we multiply the numerical coefficient, that's 6, and then x times x is x squared. And then we multiply the second two. So 2x times 4 is 8x, and that's minus 8x. Okay, how could we have done this algebraically? Well, if we look at 6x squared minus 8x divided by 2x, remember that this can be split up into two separate fractions, and it's finding the difference of two separate fractions. So we have 6x squared divided by 2x minus 8x divided by 2x. Again, you'll notice that both have the same denominator as they did in the original excuse me, the original question. So let's reduce these fractions. We can divide both 2 and 6 by 2. That goes 3 times. We divide x squared by x. Now remember that x squared divided by x, when we're dividing variables that have exponents, we take our exponents and we subtract them. So x squared divided by x, it's x to the power of 2 minus 1, which is x. Okay, so we can get rid of that x squared. It leaves only x there, and the 3 from the original reduction. Okay, here, x and x cancel. 8 divided by 2 is 4. So now we're left with 3x minus 4. Okay, and that was the answer that we ended up getting right here. Okay. All right, let's go to the next page. Determine the quotient for 3x squared plus 6x divided by 3x. Okay, I'm going to get you to pause the video, and let's see if you can figure out what the answer would be to this question. Pausing in 3, 2, 1. Welcome back. Let's have a look and see if you got it done correctly. Okay, so again we have here x, just like we have set up in our multiplication tables. What would we multiply x by to get x squared? So hopefully you put that here, and you'll notice that that gives me an x squared here because this one and this one multiply. But when it multiplies against this x, it gives me another x squared, and this one, it gives me the third x squared. Okay, how do I get multiplying an x to ending up with a product of x? Well, any number times 1 is the original number. So here we're going to put that right there and fill it in, and you should have come up with x plus 2. If you did, please take a moment, reach behind yourself, and give yourself a little pat on the back. The next example, dividing a polynomial by a monomial algebraically. Question A, and I'm just going to work through one question at a time. So what is the ratio of the surface area to the radius of the cylinder? Write the ratio in simplest terms. Okay, we need to remember that a ratio can be written like this. Surface area to radius, that's my ratio. But what is the other way that you can write a ratio? Well, we can write that as a fraction as well. So that would be surface area divided by the radius. Okay, now if I have surface area divided by radius, just as I did in my initial ratio, I will be able to reduce this fraction or reduce the ratio. So let's have a look here. We have surface area divided by the radius equals 2 pi r squared plus 2 pi rh. And that's all divided by r. Well, remember that we can split this up into two separate fractions. So that's 2 pi r squared over r plus 2 pi rh. All right. So, divided by r. So let's reduce now. Remember that r squared divided by r is r. So we're left in our answer 2 pi r plus, and what happens on this side? Well, we have r divided by r. They can both cancel, and we're left with 2 pi h. Okay. Now, what happens in question B? Well, if the height h of the cylinder is the same as the radius r, what is the ratio of the surface area to the radius? Write the ratio in simplest form. Well, here's my surface area to radius ratio. Let's write that out. That's 2 pi r squared plus 2 pi h, and both of those are over r. Now it says that the height of the cylinder is the same as the radius. So here I'm going to just erase the h, and I can write in there r, because it says in the question that the height is the same as the radius. Now we can simplify. Well, the first side here, r squared divided by r is r. Remember, that's r squared minus, so r to the power of 2 minus 1, which leaves me with r. Okay, plus 2 pi r divided by r. Well, I can cancel out my r's. And, oh, hang on a second, I forgot to put in 2 pi rh. Excuse me. So here I'm left with, when I have 2 pi rh, it's 2 pi r times r, so I can cancel out one of the r's. So I'm left on this side here with 2 pi r plus 2 pi r. Now, can I combine these any further? Well, yes, they're actually like terms because they both have the same variables and they both have the same exponents. So 2 pi r plus 2 pi r is 4 pi r. Okay, show you know. I'd like you to pause the video and see if you can do these questions on your own. Pausing in 3, 2, 1, pause. Welcome back. Let's see how you did on these two questions. All right, the first one here, if we're rewriting it, and I suggest those people that have a little bit of trouble with the reductions, rewrite them as separate fractions. It will help make it a little bit easier to see what's going on. So we have 15x squared over 3x minus 12x over 3x. So we can reduce the numerical coefficients. 15 divided by 3 is 5. X squared divided by x is x. So I'm just going to write that down below, 5x minus, and on the right-hand side here, 12 divided by 3 is 4, and x divided by x is 1. So we end up with 5x minus 4. Again, if this is the answer that you came up with, reach around behind, give yourself that nice little pat on the back. Okay, question B. Pause the video in 3, 2, 1, pause. Welcome back. Okay, let's see how you did. Minus 2t squared over 2t plus 4t over 2t. Now, you have to really watch when you have the negatives involved, because when you're reducing, don't forget that when you're canceling something, negative 2 divided by 2 doesn't just cancel out. We have negative 2 divided by 2 is that negative 1. T squared divided by t, we can get rid of the squared and it gets rid of the t on the bottom. On the right hand fraction, we have the 4 divided by 2 is 2. T divided by t cancels out, and we end up with negative 1. The t is still there, plus 2. Now be careful when you're reducing these, make sure you just put one nice line through. I've seen a lot of kids in the past, they do big scribbles, and what ends up happening is they accidentally scribble out part of the equation, so then at the end when they're putting their final answer, they forget bits and pieces, or they reduce incorrectly. All right, and that ends 7.3. Thanks for participating in filling out your notes package. Please make sure that your notes package is completely filled out, and when we get to class next day, the assignment will be page 275 to 277, numbers 4 to 15. Can't wait to see you. Talk to you soon.